Hello friends, welcome back. In our last few videos, we have started this discussion of security model and system state. These two concepts, security model and system state, are the key concepts used in describing the secure model of any computer system. And this was discussed in March 1976 research paper by Bell La Padula. That research paper is the foundation of Bell La Padula security model, which we study as part of this CISSP curriculum. Now, BIBA model is also based on lattice-based security model. As we know that the term lattice refers to layers and it has got a mathematical foundation. If you haven't watched my video where I discussed what is a lattice and what are the mathematical foundations you should know to understand a lattice, you can go back and watch my video. I will put a link here. Now, briefly, I can recap what a lattice is. The lattice is basically a set of classification and categories wherein we have the property of this set, the elements of this set having this property of being reflexive, being transitive, and being anti-symmetric. Now, these are mathematical terms used in discrete mathematics, and it's not expected for a CISSP, the person who is preparing for CISSP to know the in-depth details of these terms. But if you are willing to understand, willing to know, it will add to your knowledge. Now, having said that, you have this lattice-based security model, and two predominant lattice-based security models are Bell La Padula model and BIBA security model. I have discussed Bell La Padula model in the explanation of the research paper itself. You can go back and check that video. What was the end understanding of Bell La Padula model was that this model is highly focused on confidentiality. So it's a confidentiality driven model. Now, what happens in a confidentiality driven security model? I would like to understand the properties of a security model from the reference frame of confidentiality and integrity. Right, so we all know what a reference frame is. A reference frame is a set of parameters from where we are observing something. Now, here in the case of Bell La Padula, the reference frame is confidentiality. So confidentiality is the core of this security model. Now, what is the first thing which comes in your mind when you think of confidentiality? The very first thing I can think of is giving no read access, right? So if something is confidential, I will try end user not to read that document or not to access that document. So this is first property which we should know as part of Bell La Padula security model, that it enforces no read up, right? So if you are a subject, a user, and you have certain security classification associated with you, and that security classification says you are at classification X, or in a general way, if you are at a classification secret, then you can't read up to top secret. This property is called simple security property. You know why this is? Because this is very simple. This is something which is very prompt in understanding any system which is confidentiality driven. So the principle of confidentiality says that I don't allow any subject to read any document which is at higher classification level. So no read up. Now if this is the flip side, the flop side is no write down. So I will not allow any subject to write any document below its security level, right? So these are the two properties which we should keep in mind. First is simple security property, which is no read up. You can't read any document or any data above your classification level, and you are not allowed to write any information below your classification level. This also enforces confidentiality. It means that you are at a confidentiality level, let's say secret, and there is another confidential level which is private. Now you can't leak the confidential information to the private classification, right? So this is something which is also giving a hint of having confidentiality as the predominant nature of the model. So simple security property is no read up. Then you have got a star property which says no write down. And there are two rules which are implicit. It means that you can read and write at your own level. Sometimes it is referred as a strong star property, right? So you can read and write out at your own level, which is allowed, but you can't write below your security level and you can't read up your security level. This also implies that you can write to a security level above your security level, right? There is no harm in confidentiality in that case, and you can read below your security level. That is also putting no harm to the confidentiality level. So if you look this whole Bell La Padula model from the reference frame of confidentiality, it will make a total sense that you are not allowing any subject to kind of jeopardize the confidentiality of the information by enforcing simple security property, no read up, star security property, no write down. But with this two simple and star property, the shadow property is that you can write up and you can read down, and you can read and write at your own level. This is what is Bell La Padula model in simple terms. Now there is one more property I missed into this discussion on Bell La Padula model, which is discretionary access control, right? So when this word discretionary comes, it means by decree, like by by administrator's intervention. So but here in Bell La Padula model, you can think of discretionary access control is kind of a matrix where you have subject and object, and you have a cross section of subject and object referring this subject can access this object with what access attributes. Like it, in the original Bell La Padula research paper, we have seen there are 4 access attributes which are execute, read, append and write. So one subject can access one object, and what kind of access it can have. It can have an execute access or read access or append access or write access. So this is discretionary access control. The very important thing which we should have in our mind when it comes to discretionary access control is that discretionary access control should not violate simple security property and star security property, right? So discretionary access control can be enforced into a secure system which is following Bell La Padula security principles of simple security property and star security property or a strong star security property. And if there are multiple departments and multiple kind of containers in your security model, then you can have an access matrix on top of that rule, which governs different type of subjects which are in different departments, different type of objects which are in different categories, and you can have a matrix showing which subject can access what object, and this subject and object relationship should not violate the two main properties, which are simple security property and star security property. I hope this was useful for you. Next video we'll look into the BIBA security model, and we'll discuss some of the properties of the BIBA security model, and we'll see how it is integrity driven.